So let's see position in a plane. Our topic is motion in a plane. Motion in a plane, right? So let's see the next topic, that is acceleration. Acceleration. So how it is defined? Right, average acceleration of an object for a time interval delta t moving in xy plane is the change in velocity divided by time interval. So how it is defined? As change in velocity upon change in time, right? So delta represents change, so it will be delta vxi plus vy of j divided by delta of t. Now divide individually, then it will be delta Vxi by delta T, delta of Vyj divided by delta of T, right? So this is the expression for acceleration in the terms of change in velocity by change in time, right? So the graph can be given in the form of like this. Suppose this is x-axis, this is y-axis. So it is starting from here. Its velocity in x direction is Vxi, and on the y-axis it is V of y of j, right? So this will give the resultant velocity V, right? So this will give the direction of acceleration, right? Or Vx can be written in the form of angle theta will be V cos theta, and for the y component it will be V of sine of theta, right? Now see the next part of this one, this expression. So delta x, delta Vx by delta t can be written as axi, acceleration in x-axis plus acceleration in y-axis in the direction of j. So this is the resultant acceleration value, right? And it is also called as average acceleration. Average acceleration, right? Now see the expression for instantaneous acceleration. So it is defined as limiting value of the average acceleration at the time interval that approaches to 0. So it is called as instantaneous acceleration. Instantaneous acceleration, right? So A is equal to limit delta t tends to 0. So delta V by delta of t, right? So we have applied here limits. So take the another color, then it will be right in the form of delta Vx and delta Vy. So again A can be written as I limit delta t tends to 0 delta Vx upon delta of t plus j limit delta t tends to 0 delta Vy upon delta of t, right? So limit will become axi plus ayj. So this will be the expression in the ax and ay of acceleration, and this is called instantaneous acceleration in the expressed form of x and y. So please write up to this point. Now see the different types of graph, right? So first graph will be based on average acceleration for 3 time interval A, T1, T2 and T3. So first look at for T1, right? So that will be average acceleration at time t1, right? So in x-axis, this is your origin, this is your y-axis, right? This is your point P. P is position and velocity is v, right? So it starts from P and into the P1 point position, P1 position, right? So this will give the position vector, and this instantaneous point will be give the velocity, instantaneous velocity, that is v1, right? And direction of acceleration will be like this. So this is the direction of acceleration, right? So for that I will write the resultant velocity. So this is your v velocity and this is your velocity v dash, right? This is for position P and this is for position P1. So what will be the resultant? So resultant will be this point joining. So it is delta of v. So this will give the change in velocity, right? Change in velocity. Understood? So now see the next second case. This is the case 1. So second case, this is the x-axis, this is y-axis. This p is the position vector of the object, velocity is v, and it is moving from position p to p2 dash p2 at time delta t2. Yes. So this will give the direction, that is v dash, right? And direction of acceleration will be like this, a dash, right? When we draw the diagram for velocity, this is your v, this is your v dash, and this will give the resultant velocity delta v, right? So for this is your tail 1, this is head 1, this is tail 2, head 2, right? So delta v will be the change in velocity, right? For time being delta t2. In the similar manner you can write for others also, right? So now see the numerical, and for finding the resultant angle of velocity, that will be given by vy by vx. In the previous slides we have derived also, right? So now solve example number 4.4 after writing this one. Let's see the example 4.4. So position of the particle is given by, so r is the position, that is given by 3.0 t of I plus 2.0 t square j plus 5.0 of k, right? So t is your time in second, right? And coefficient have the proper unit for r to be in meter. So r unit is meter. Find the velocity, acceleration, right? First find velocity and acceleration, right? For velocity as a function of time is defined as change in position by change in time. So differentiate the given position vector, that is 3 of t of I plus 2 of t square j plus 5 of k with respect to delta t. So answer will be 3. T differentiation is 1. So it is 3 of 1 plus 2. Power is 2. So 2 will be outside and t raised to 2 minus 1 of j. This is I vector plus 5 is constant, so it will be 0 of k, right? So do you know the basic differentiation rule? When y equal to x square, when we differentiate dy by dx, then it will be n x raised to n minus 1. So this is the differentiation formula. And when y is equal to constant c, so its dy by dx is 0, right? So here we have applied that rule. So I will give you here. Suppose y equal to 2, t power is 1. So when dy by dt I am differentiating, so 1 will be outside, t raised to 1 minus 1. So t raised to 0 is nothing but it is 1 only. So it is dy by dt is 1. For t it is 1. In the similar manner, when y equal to t square, and when we differentiating with respect to time, so 2 will be out, so it is 2 t raised to 2 minus 1. So answer will be 2t, right? Understood this point? So I have applied here for t, differentiation is 1, right? So 1 I have written here, and for t square I have written 2 t raised to 2 minus 1, and this is 0, right? So this is the expression of velocity in the time in the form of t. Understood?
Yes, sir.
Okay. Now we have to find the acceleration as a function of t. So for that I will differentiate the velocity with respect to time. So again differentiate this function. This is equation 2. This is 1. So this will be. So you can see here this is constant, right? So constant differentiation is 0. So its answer will be 0 of I plus. This is 4t. So t value is 1 now. So t 1. So it is 4 of j plus 0 of k. So acceleration in the terms of a will be only 4 of j. Understood? 4j answer. Understood? So you can see here direction is j. It means acceleration is in the y direction. Acceleration is in y direction. Understood? And you can see velocity direction is one is in x-axis and one is in y-axis, right? There is no component in z-axis. So this will represent the j, but there is 0 value. So this is the value of velocity and acceleration for the position vector 3ti plus 2t square j plus 5k. So please write this solution. If it is asked find the resultant velocity, then it will be vx square plus vy square. So vx value is 3, right? So it is 3 square plus 4 square. It is 4 now. So it will be 5. So answer will be 5 meter per second. And when we find the resultant, so it will be vy by vx. So vy is 4 and vx is 3. So it is angle is 4 by 3, right? That will be theta is equal to 53 degrees. So please write this one, add that.